Okay, so when we're looking back at the original series in number 1, find the sum of the first 10 terms. If we're starting with 2, which is the first term, and then 1 minus, what did we say? We're multiplying by 5. And that 5 is raised to the 10th power. That's a big number. We divide by 1 minus 5. We go back to the old calculator. I don't know 5 to the 10th power. That's a big number. 1 minus 5 to the 10th. And then if I divide that by negative 4, which is what I'm dividing by, that's in the 4 million category, big. 4,882,812. And if we go ahead and do that same thing with the first 11, you do 2 times 1 minus 5 to the 11th power. The clever ones among you will not go through this whole process again. How come? Well, I'm glad you asked. I'll tell you in a sec. You go back, do that, change that to an 11, divide that by a negative 4, and that there is 24,414,062. And the question, how much bigger is the sum now?
Come and look it.
It's how much bigger. What did we add to that? We added another 20,000, or close to 20 million, 19 million.
Daddy.
Okay.
Look at that one.
That's good, good.
That's a new one, really.
But essentially what's happening is you're adding the next term in the series, right? Okay. What you're doing is you're adding 2 to the 11th power. Or no, you're adding whatever you get when you plug 11 into that equation right there. Okay? You multiply the previous equation by 5, and that's what you're adding. So if we're multiplying the previous one by 5, oh yeah. Well, is it possible? Here's the question. Boiling down, we keep going through this process. How much bigger is the sum now? You subtract 4882, 812. It's 19,531,250. That's how much bigger it is. And that number basically is 2 to the 11th power. Oh no, it's 5 to the 11th power. Sorry, my bad. Anyway, the question is, how big is this thing getting here? How much? What exactly is it that we have to continue to do here? We are. Is it possible to find the sum of an infinite number of terms in this series? The answer is no, because it just keeps getting bigger. So as the number continues to rise, we're just adding another larger term to it. And so there's no limit to how big it'll be because it continues to get bigger. What we'll find is that we'll be able to find a sum of an infinite number of terms as long as the multiplier makes us get smaller and smaller. And so we saw that with we either saw that with the activity of 17.2 sidebar, whether it was done today or tomorrow. Hopefully that helps.